Good day everyone. In today's tutorial we're gonna learn how to prove this expression using simple techniques. So stick around and watch to the end. Don't forget to like this video and drop a comment. So let's get to work. First thing I'll do is to learn this sum s. So I have that s equals the sum to infinity, to n of I starting from 0 of minus 1 to the power of I divided by I plus 1, then multiplying the binomial n and I. Okay, so first thing I'll do, please note that 1 over I plus 1 is the same as the integral from 0 to 1 of I to the power x to the power of I dx. Okay, so let me apply this in my sum here. I have that this is equal to the sum to n of I starting from, okay, let me correct this. This is from 0 of minus 1 to the power of I, then multiplying the binomial n and I. Then here comes my integral. So this is it. Let me extract my integral sign outside. So I have the integral from 0 to 1 of the sum to n of I starting from 0 of minus x this time around to the power of I dx. Okay, multiplying the binomial n and I dx. Now let me apply binomial theorem. I have that this question is the same as the integral from 0 to 1 of 1 minus x to the power of I n dx. Okay, so let me apply something here. Let's order. Let me introduce something. It's called King's property. It states that the integral with a defined interval of a function f of x dx is the same as the integral with the same interval of function a plus b minus x, alright, dx. So let me apply it in this case. So for my question, I have that this is the same as, the s is the same as the integral from 0 to 1 of 1 plus 0. Okay, no, this is 1 minus. Now replacing x with the integral, I have 1 plus 0 minus x, just like the King's property, what it states, dx. So this is equivalent to the integral from 0 to 1 of, let me expand this, I have 1 minus 1 plus x to the power of n dx. So this is same as the integral from 0 to 1 of x to the power of n dx. So applying the normal integral rule, I have that s is equal to x to the power of n plus 1 minus n divided by n plus 1, then evaluated from 0 to 1. So this is 1 to the power of n plus 1 divided by n plus 1, then minus 0 to the power of n plus 1 divided by n plus 1. So what am I left with? This is 1 over n plus 1. So I've been able to prove that the sum to n of I starting from 0 is a minus of minus 1 to the power of I divided by I plus 1 multiplying the binomial n and I is the same as 1 over n plus I. So thank you for watching. So don't forget to like this video, drop a comment on how you feel. Do you have another technique? You can also say it there, and don't forget the channel if you've not done so. Thank you.